Hello, I'm Paula Mártire, and I will discuss our recently published work in the Royal Society of Chemistry Applied Interfaces. As a PhD student in the soft matter laboratory in La Plata City, Argentina, I am part of a multidisciplinary team which explores the relationship between molecular structure, molecular function, and microscopic properties. Our focus is on designing and building soft material devices for biosensing and energy applications. In my thesis, I am studying modified electrodes, specifically for electrocatalysis and supercapacitors. Supercapacitors are environmental-friendly devices with excellent energy storage capabilities and rapid charge-discharge rates. In our last research, we incorporated a Ferrocene-labelled surfactant into an electrode film to improve supercapacitor performance. This study explores the development of a neutral aqueous supercapacitor material using a combination of polyaniline and carbon nanomaterials through layer-by-layer assembly. By applying this assembly process, nanoarchitectonics can be employed to create desirable nanostructures on the electrode surface. The aim of this study was to include a redox-active surfactant as a carbon dispersant. In particular, we use a Ferrocene-labelled setup which exhibits redox activity and enhances the capability of the hybrid coatings. The growth of the film was studied using UV visible spectroscopy and quartz crystal microbalance. We compared the electrochemical response of coatings with different proportions of ferrocene. The voltammetric current increases with the proportion of Ferrocene-labelled surfactant used in the assembly process in both acidic and neutral solutions. We also performed galvanostatic charge-discharge curves and studied the cyclability up to 1700 cycles. The integration of the ferrocene moieties increases the capacitance of the electrodes without significantly changing the electrochemical stability and cyclability. This approach synergistically combines carbon nanomaterials, electroactive polymers, and the Faradaic contribution of the electroactive surfactants. This results in a supercapacitor material with excellent performance and potential application in wearable devices for secure energy storage. In the future, I will continue to study electrodes modified for supercapacitor application and investigate the possibility of including carbon from alternative sources. In particular, we are interested in studying the application of porous carbon obtained from the pyrolysis of metal-organic frameworks. If you want to know more about our research, please consult our social media.